Let's look at rationalizing the denominator when we have the fifth root of 4x in the denominator. Let's see what we got to do here. Again, the trick is this. We want to figure out a way to get something inside the radical that is a fifth power. Because if we have a fifth root and we have a fifth power, they cancel each other out, and then we get something with no radical at all, and that's what we'd really like. So what might, let's see, 4 is really like 2 to the second power. So if I multiply by 2 to the third, well, we want to get maybe 2 to the fifth power is what we'd like. So what we'll do is we'll multiply by 2 to the third power. So 2 to the third times 2 to the second gets me 2 to the fifth. Since we have an x here, we'll multiply by x to the fourth power, and that'll get me x to the fifth. Now, I have to take this, whatever I multiplied by, I have to do that on the top as well. So I'll make that times 8x to the fourth, the fifth root of 8x to the fourth. And so on top we get 18, fifth root of 8x to the fourth, and on the bottom we'll get something nice and clean. This will actually be 2x, so yay. And then on top we still have 18, and it'll be the fifth root of 8x to the fourth. Now, since we ended up getting a 2 here and an 18 is there, we can do some canceling. That'll get us 9, and so we end up with 9 times the fifth root of 8x to the fourth, and that's all over x, and that's rational. We've rationalized the denominator, and that's what we're trying to do. So that is how we go. So again, just in case you want to make a note to yourself, what we're trying to do is, because we have a fifth root, we want to have things inside the radical that are to the fifth power. So if I have something like 4, which is 2 squared, I multiply times 2 cubed, so I get 2 to the fifth. And if I have something like x, which is x to the first power, I multiply times x to the fourth to get x to the fifth. And then voila, we are free from the radical in the denominator.